Okay, so finding the maximizing area. Okay, so let's say there's a policeman has 200 feet of caution rope, and there's two crime scenes, 1 and 2. He needs to get enough rope. He wants to know how much rope he's gonna be able to put around the crime scene, so he has to go around both of them and across. Okay, so first of all, so this is crime scene 1 and crime scene 2. And has to put enough rope around both of them and through the middle, so they're both separated. So we could label these ones right here, these sides Y and these sides X. So the first thing we do is write the area equation for this. So area is these two X's, which count for 2X, and this side right here, which is Y. So our area equation would be A area equals 2X times Y. So that's our area equation. And the perimeter equation is going to be X, X, 2X, 3X, 4X. So that's the first part of our equation, 4X. And then Y, Y, Y. So that's 3Y. So it's going to be plus 3Y. And the total perimeter is equal to 250. So that's our perimeter equation. And there's our area equation. So the first thing we have to do is solve for the Y in our perimeter equation. So it's 4X plus 3Y is equals to 150. Subtract 4X from both sides. And divide the equation by 3. So it ends up being Y equals negative 4X over 3 plus 250 over 3. Okay, so after that we look and pretty much we have our equation already in there. Pretty much we already found Y. So now what we need to do is plug in Y to the area equation, so we could have an equation. So we go and plug it in. So 2X and Y, instead of putting Y, we could replace it now with its equation. 4X 3 plus 250 over 3. So we distribute and we get negative 8X squared over 3 plus 500X over 3. And that pretty much is our equation. We could plug that into our calculator and actually find the maximum like we did in the previous concept. But there's another way to solve it, using negative b over 2a. X equals negative 2b over 2a. So x would equal 500 over 3 divided by 2, negative 8 over 3. So we plug that in, it would be negative 16 over 3 and 500 over 3. So we multiply this by the reciprocal. This cancels out. This cancels out. Negative 6, so this is going to be 500 over negative 16. Let's see. Okay, let me plug that into the calculator. Let's see. So 500 divided by negative 16 is equals to negative 31.25. And that's our x. So then once we have our x, we go back all the way up, and this is equals to negative 31.25. All these x's are worth negative 31.25. So after that, we go back to our perimeter equation, this one right here. I could plug in 4, and x, we could plug in negative 31.25 plus 3y equals 250. 250. Okay, so 4 times negative 31.25 would be times 4. It would be equal to negative 125. Actually, it's not supposed to be a negative, so right here when we divide a negative 16 with 100, it's supposed to be negative 500 too. So that would equal positive 31.25. Okay, so being that positive 31.25, we'll end up with positive 125. So positive 125 plus 3y equals 250. So we can subtract 125. We get 5. Wait. Yeah, you get 125. So that is equal to y. I mean, yeah, that's our y. So once we do that, okay, so once we do that, we try to find the dimensions. So this would be over here. So 31.25 plus 31.25, that would be, so the total line right here would be, I need more space, 62.5 times feet times 125 feet. That would be the dimension for area. And what else? Okay, once we have that, we plug that in to look for our maximum area. So we would put in into our area equation. A is equal to 231.25 and 125. So we plug that in to our calculator. So 231.25 times 125, we get 7,812.5 as our maximum area. And so this is our maximum area of our equation, and that's how you solved for the maximum area.